We've been spending some time on problems of the day, and even in 7th grade math class, with a very specific pattern. The way it came up in problem of the day on Friday was the idea of triangular numbers. Well, we all know the square numbers are, if I have a side of 1 and 1, my area is 1. Then the next square number is 4, because 2 times 2. So these are the square numbers. And just as we've become familiar with square numbers, triangular numbers also have a place in many kinds of math problems. So the way the triangular numbers look is this. 1 dot, the first triangular number has 1 dot. The second one has a base of 2 and then 1 above it. The third one has a base of 3, a row above that of 2, and 1 above that. And then, as you can imagine, the fourth has 4 on the bottom, then 3, then 2, then 1. So the number of dots in the first triangular number is 1. The number of dots in the second is 3. The number of dots in the third is 6. The number of dots in the fourth is 10. We can think of that also in function machine form. The first triangular number is 1. The second triangular number is 3. The third triangular number is 6. The fourth is 10. And many students immediately say, well, I'm adding 2 to this one, and then I'm adding 3, and then I'm adding 4. So a couple of things about that. Of course, you're adding these 2 to the first triangular number. Then you're adding these 3 to the second triangular number to get the third one. Then you're adding 4 to get to this triangular number to get the fifth one. So of course that makes sense. You can also see from looking in the function machine form that it's not going up at a constant rate. It's going up first by 2, then by 3, then by 4. So without even drawing, you can imagine that the fifth triangular number is 15. But it's a little bit hard to say exactly what that pattern is. So let's look and see what this all means. If I were to think about how I was going to find, for example, the sixth triangular number, I could draw it. If I didn't have the function machine and I couldn't just keep adding, I could say, well, I know the sixth triangular number has 6 dots in its bottom row, and above that it has 5 dots, and above that it has 4 dots, and then 3, and then 2, and boy, it just fit, and then 1. So I have to add this 6 in the bottom to the 5 above it. This has 6, this has 5, and then 4 in the next row, 3, 2, 1. Seems to me we've added consecutive numbers like this before. We can see that this one is 7. Oops. This one is 7. This one is 7. So you can see that I have 3 7s. How did I get the 7? I got it by adding 1 to 6. So in the sixth triangular number, I add 1 to it, and then I have 3 groups. In other words, 6 divided by 2, because each one of these has a partner. Let's look at 8. 1, 2, 3, 4, 5, 6, 7, 8. And then that's above